t-test and the significance of the difference between two correlated means.
William Seeley Gosset. He was born on June 13, 1876 and died October 16, 1937. He was an English statistician, chemist, and brewer who served as head brewer of Guinness and head experimental brewer of Guinness, and was a pioneer of modern statistics. He pioneered small sample experimental design and analysis with an economic approach to the logic of uncertainty. Gosset published under the pen name Student and developed, most famously, Student's t-distribution, originally called Student's z and Student's test of statistical significance. T-test. A t-test is a type of inferential statistic used to determine if there is a significant difference between the means of two groups, which may be related in certain features. It is mostly used when the datasets, like the dataset recorded as the outcome from flipping a coin 100 times, would follow a normal distribution and may have unknown variances. A t-test is used as a hypothesis testing tool which allows testing of an assumption applicable to a population. Correlated or paired t-test. A correlated t-test is performed when the samples typically consist of matched pairs of similar units, or when there are cases of repeated measures. For example, there may be instances of the same patients being tested repeatedly before and after receiving a particular treatment. In such cases, each patient is being used as a control sample against themselves. This method also applies to cases where the samples are related in some manner or having matching characteristics, like a comparative analysis involving children, parents, or siblings. Correlated or paired t-tests are of a dependent type, as these involve cases where the two sets of samples are related. The formula to be used will be the following. T is equal to the summation of D over N divided by SD over the square root of N. The second formula is SD squared is equivalent to N times the summation of D squared minus the summation of D quantity squared divided by N times N minus 1. The last formula is dF is equivalent to N minus 1. D stands for the difference between the two correlated means. N represents the number of observations. SD is a standard deviation of the differences. And dF, or degree of freedom, signifies the number of independent information available for computing variability. We will be practicing in 3 different exercises to further improve our understanding on the topic. Exercise A is titled Pre-test and Post-test, to determine whether the student's performance in college algebra will improve after enrolling in the subject for 1 term. Exercise B is all about before treatment and after treatment, to determine whether the condition of cancer patients will improve after treatment. Exercise C is going to talk about shoes off and shoes on, to determine whether people are taller when they are wearing shoes. The first step in solving this type of problem is to formulate the null hypothesis. In formulating the null hypothesis, follow the format in the given example. In this case, the two means that are compared are pre-test and post-test. We negate that there is a significant difference between the two correlated means. The final null hypothesis would be there is no significant difference between pre-test and post-test. After formulating the null hypothesis comes the testing of the null hypothesis. We will be filling in the table with the correct answers. There will be 5 columns, namely the N, the two means to be compared, the difference between the two correlated means and the square of the difference of the two correlated means. Next, get the summation of the difference and the summation of the square of the differences. We also identify the n by counting the number of rows. After obtaining all the values, we will substitute those to the formula. We will be solving first for the SD squared because it is not found in the table and it will be needed to solve the t. N is equals to 10 times the summation of d squared, which is 20,998, minus the square of the summation of d, that is 440, divided by 10 times 10 minus 1. The answer is 148.91. Now that we have the SD squared, we remove the square because what is needed in the first formula is SD, not SD squared. We will square the value to remove the exponent too. So the square root of SD squared will be SD, and the square of 148.91 will be 12.20. Now that we have the value of the SD, we will proceed to solving the t. Replace the formula with the values and solve. 440 over 10 divided by 12.20 over the square root of 10 is equals to 11.40. The last step in testing the null hypothesis is getting the tabular value. Before we get the tabular value, we need to solve for the degree of freedom. The df is equals to the n minus 1, so it becomes 10 minus 1. The degree of freedom is 9. Correlated means we use the df to locate the appropriate tabular value. In this example, the degree of freedom is 9, which means that the tabular value will be 1.833. Making the decision. In making the decision, we will decide whether the null hypothesis is rejected or not. If the computed value is greater than the tabular value, the null hypothesis is rejected. If the computed value is lesser than the tabulated value, then the null hypothesis is accepted. In this example, we can see that the computed value is greater than the tabular value. This means that the null hypothesis is rejected. When the null hypothesis is rejected, it becomes the opposite. It becomes positive. In this exercise A, the final decision will be the null hypothesis is rejected because the computed value is higher than the tabulated value. There is a significant difference between pre-test and post-test. In this second example, you can try by solving all by yourself. The steps will be shown. Now we are testing the null hypothesis, which is the second step. The degree of freedom is n minus 1, which is 10. Now we have side. Now our null hypothesis will be rejected. This will be the last exercise in this video, exercise C. So let us all please pay attention. You can now solve all on your own with the help of the previous examples, but rest assured, all the steps will still be shown in this final example. The name of this example is shoes off and shoes on. The first step is to formulate the null hypothesis, and it will be there is no significant difference between shoes off and shoes on. Now we will be proceeding to the second step, which is testing the null hypothesis. All we got to do is fill in the table here. and then get its summation, and then replace all those values with the formula given. But first, we'll be solving for the SD squared. Since it cannot be found in any part of the table, which will be needed in solving the t, the answer for the SD squared will be 2.27. Now that we have the SD squared, we will solve for the SD, which is 1.51. Now that we have all the values, we'll replace those with the t, and the answer will be 8.03. Now we get to the table of values, we need the degree of freedom. The degree of freedom will be 11. Now proceeding to will be 1.796. That'll be our time. The null hypothesis will be rejected. That is all, everyone. I hope you learned a lot from this video. Thank you for watching.